Hey guys, welcome to this video. So in this video I'm gonna talk about the some important fundamental problems in modern science, mainly physics. So first of all, let me tell you that I'm using this book as a reference. I recently got this book, The Trouble with Physics by Lee Smolin. It's a great book. So I'm not yet done reading this book. But it's a great book. So this book actually helps to clear some of the misconceptions which you have regarding physics, and it's a very great book, especially if you want to know about string theory in some detail, but in layman's term. After all, it's a popular science book. It's not a technical book. The Trouble with Physics. So the point is, in the first chapter, the 5 great problems in theoretical physics, the author points out the 5 major problems in theoretical physics. In this video, I'm going to talk about these 5 problems plus one important thing, one more problem, which I'll be discussing near the end of the video. So let's get started. The first problem is, so many people are under the impression, like if you have read popular science books, and if you read a little bit about physics and stuff, so many people are under the impression that in physics everything is set. We just need to unify gravity with the other 3 forces of nature to get a final theory. We just need to determine whether string theory is the correct approach, or loop quantum gravity is the correct approach, or maybe something else, and then we are done with the theory of everything, and then that's it. This is a totally wrong idea, totally wrong impression, because first of all, see, string theory, loop quantum gravity, whatever we are saying, these theories have no experimental support, and these theories, they leave a lot of questions unanswered. So, and we do not have the technical apparatus, we do not have the technology to carry experiments that will prove the. See, when you're saying experiments that will prove this theory, I am talking about experiments predictions which are made only by these theories and not by any other theory. So such predictions, and even if such predictions are there, we don't have the technology to experiment on them, right? So that's the main problem. And plus, string theory, loop quantum gravity, these theories are all based, like they are all based on the, like, see, one thing it's very important to realize, we are working on our ancestors, like what they did, Einstein, Niels Bohr, Schrödinger. We are working on their model. But in physics, the situation is such that I sometimes question myself whether we need a radical revision, whether we need, like, maybe something entirely different way of looking at the world. Because, for instance, I'll be discussing that in a short time. The first problem, which I mentioned 5 problems about the main 5 problems in physics today, theoretical physics, plus one more problem which is not there in this book, but I will be discussing it. That's also an important problem. So 6 problems. Number 1, making sense of general theory of relativity and quantum mechanics. So here, I think all of you know that general relativity describes gravity. It's an astronomical phenomena, like on large scales, and it is sort of like a theory based on the geometry of space-time, curvature of space-time, and the presence of matter energy. So it's the general case of the special relativity, and it has been verified experimentally. It's a very successful theory actually, but the problem is that quantum mechanics deals with the other forces of nature. Now again, in electroweak theory, we have a unification of electromagnetism and weak nuclear force. Strong nuclear force, you can say, in some sense has been unified in the standard model, but the standard model, again, there are a lot of problems with the standard model. It's not a complete theory. Alright. So basically, these kind of things, so the thing is that general relativity and quantum mechanics, both of these are fundamental theories. They describe a fundamental force of nature. But the problem is, these 2 theories, they are like, if this is true, then this cannot be true, or if this is true, then this cannot be true. So they are contradictory theories. But the thing is that if both of them describe fundamental forces of nature, and this nature is one, it's not like we have a separate set of laws for the quantum world. It should not be like that, right? That we have a separate set of laws for the quantum world and a separate set of laws for gravity. It should not be like that. One nature and everything is interacting in it, so we should have one set of laws. So that is the problem. The problem lies in unifying these 2 theories, because it's very difficult to unify general relativity and string theory. Like there are and quantum mechanics. So there are some approaches like string theory and loop quantum gravity. So string theory means, see, string theory is a mathematical theory. So it gets around the problem of, like for instance, renormalization. That's a very important concept in physics, renormalization. But I will not go into that here. Then for instance, loop quantum gravity, it treats gravity in a quantum mechanical way. Like it divides space-time into loops, sort of network of loops. But these are, again, there are a lot of open questions. None of these theories are well established. Now, one point which this author makes in this book is that string theory has a lot of support in the academic. Like almost all new physicists, they are working on string theory. But actually, we should be open to other theories as well. We should not be too much focused on string theory. We should be open to all the other theories, because string theory has everybody is biased towards string theory. So that's a bad thing about physics. Bad thing about this is not the way we should practice science. Obviously, string theory has some compelling evidence, some beauty. Like we cannot ignore it that easily. Maybe it's true, but yeah, you know what I mean. Like, other approaches are also promising, and other approaches are also worth trying out, right? So, and string theory, see, however beautiful it is, however good it is, there are still a lot of problems with string theory. So this is our first problem. The next problem is see, the standard model. So today we think that the standard model is almost a complete theory. It's a very good theory, but actually the standard, and it has survived many experimental results, many experimental tests. But the reality is that standard model is a very incomplete theory. There are some predictions which simply do not match, like the muon G minus 2 experiment, which was recently published, the results of which were recently published. You can go check it out if you're interested, the muon G minus 2 experiment. Then it was recently discovered that neutrinos have mass, but according to the standard model, neutrinos should not have any mass. So from where is this mass coming from? Then there are other theories, that predict the existence of more particles, supersymmetry and those things. So basically, it's not a complete theory. One more reason. In standard model, there are a lot of arbitrary constants. Arbitrary constants in the sense, there are some values which we need to find experimentally and just plug in, and it works. Experimentally it is verified. But we don't. The standard model does not really explain from why these values are what they are, why they are not something else. Like then there are some other problems, like we have three redundant generation of fermions. Why? Like again, there is a concept that the Higgs boson, from the Higgs boson, mass is trickling down from the third generation to the first generation. So there is a concept of mass division, like among the three generations. So and there are other physicists who have shown that we need three generations actually, but still some consider it to be redundant. So that's also one problem. And it is a main problem that we have to make sense of the constants. There are so many arbitrary constants in such a fundamental theory. That's our second problem. Third problem says that about dark energy and dark matter. So in cosmology, so quantum mechanics, that's all right, but in cosmology also we have a similar kind of problem. That is, see, like when we have been noticing the galaxies, like the galaxies, we are seeing that the stars which are rotating on the outer orbit of the galaxy, on the outer edge of the galaxy, they are moving too fast. They are moving fast enough that they can break free of the gravitational pull of the galaxy and they can escape. Yet they are not breaking free. Yet they are being held on. They are held in place by the galaxy. According to Newtonian mechanics, they have enough speed to break free, but they are not breaking free. This means there must be some extra mass in the galaxy. Plus, if you try to calculate the mass of the galaxy, like by seeing all the elements, all the stars, all the like clouds of gas, everything, that mass which you're getting and the mass which you're calculating by some other means, they are not matching. And the value of mass which you're getting by just seeing all the elements, it's almost always like lesser than the actual value of mass which you're getting from Newtonian mechanics. From Newtonian mechanics also you can calculate the mass of the galaxy. So this means what we are seeing, the stars and the elements, must be something else, because the mass of these elements cannot account for the total mass of the galaxy. The total mass is much greater than that. So there must be something else in the galaxies which we cannot see. Which we cannot see in the sense dark matter, because we don't know what dark matter is. We know very little about them. Look, there are again theories, but the thing is that it's mainly a kind of matter which does not interact with the electromagnetic, like it does not give up light, so we cannot see them. That's why it's called dark matter. So now it's all just speculation. We are just postulating the existence of a matter of which we don't know, just to explain away some experimental anomaly. Same for dark energy. The rate of the expansion of the universe, we all know this redshift expansion of the universe and these things, but the rate of the expansion of the universe is much faster than it should be. So then it was suggested that dark energy is something which acts only when very large distances are taken into consideration, and this dark energy is responsible for accelerating the expansion of the universe. Again, this is just we are postulating dark energy. We don't know what dark energy is actually. So this is a major problem in physics. 3 problems we have already discussed. Next problem is we have to see one problem we discussed, that we have to unify gravity with quantum mechanics. Next problem is we also have to unify the 4 forces of nature. Now these 2 problems are not exactly the same thing, because when I say unify the forces of nature, there are many ways you can do it. Like some people are trying to find the graviton, the boson for gravity. Some people are trying some other methods. Like you have to unify the 4 forces of nature into a fundamental force. But the thing is that these 2 problems, the gravity and problem of quantum gravity, you can say, like quantum mechanics and general relativity, these 2 problems are highly interdependent. To solve one, you have to solve the other, and vice versa. So I think I don't need to say much about this. You all know what we mean by unification of the 4 forces. Like there are 4 fundamental forces, so we have to unify these forces into a single theoretical framework, and that has not been done in a satisfactory manner, right? Electricity and magnetism successfully united into electromagnetism. Electromagnetism and weak nuclear force successfully united into electroweak theory. But after that, there are some problems. Even in standard model, even in grand unified theory, there are some problems, and gravity has always remained a problem. The last problem which I am going to discuss, last problem among the 5 problems. After that, I will be discussing my problem. My problem, in the sense, it's a well accepted problem, but it's not in this book. Okay. So before that, the last problem among these 5 problems. This is the problem of quantum measurement. This is a very, very fundamental problem. So, like, initially it was thought that in Newton's days and everything, that physics should describe the world as it is even if we were not present, even if we were absent. Here the first question arises, did we just accidentally come to the world? Like, did just life accidentally emerge and we are just accidentally coming to the world and witnessing all the phenomena and trying to make sense of the world around us? Or is consciousness something fundamental? Is consciousness something that is the only real thing? Is everything else a part of consciousness? Is consciousness something that has been present from the very beginning? So if the latter is the case, if consciousness is absolutely fundamental, then obviously, like, then everything is observer dependent. We cannot separate the observed and the observer, like these things you know in quantum mechanics. Like in quantum mechanics, the act of observation can affect the outcome, like the measurement problem. Like we know this, Schrodinger's cat experiment and so on. So, but it's usually the realist people, they don't believe in this. They believe that the reality does not depend on our minds. The reality will exist even if I am not here. Even if there is no conscious being in this universe, not I. Even if there is no conscious being in this universe, the reality would exist as it is. Some people believe this. Now, if you ask me, I personally side with the solipsists. I personally believe in the solipsism view, like the view that. Now, again, this is my personal opinion. I don't want to force this upon. Obviously, some people side with Einstein and all, but I personally believe that consciousness plays a fundamental role. And I personally also believe that consciousness and physics should be unified. That is the 6th problem. I'm coming to it. So the 5th problem is this problem, that whether the reality exists outside of our minds independently, or whether it's all observation dependent, whether we are creating the reality. Then in that sense, everything is an illusion. And there are many metaphysical arguments or metaphysical issues that will arise. So this is, according to me, now if you ask me, among these 5 problems, which is the most important problem that should be solved immediately in the sense, all the problems must be solved for physics to evolve, for physics to progress. But if you ask me which problem should be solved immediately, like not immediately, but which problem is the most important to solve, most crucial for our overall understanding of the world around us. I would say this last problem, the last problem which I discussed, this measurement problem in quantum mechanics. What is quantum mechanics telling us about the fundamental nature of reality? So the most obvious solution is that quantum mechanics is an incomplete theory. Quantum mechanics cannot be a theory of everything. But still, I don't believe the realist point of view. I believe in the solipsist point of view. I think I'll be making some videos about realism and solipsism in detail. So please stay tuned and subscribe to the channel. Next problem, the last problem which we'll be discussing in this video. So this is the very fundamental problem, the problem of consciousness. So some people say that consciousness and physics should not be mixed up. Like they are totally separate fields. Like consciousness should be understood in terms of artificial intelligence or neuroscience, neurology. But yeah, that's it. But consciousness, according to me, is a very fundamental phenomenon. I believe that consciousness is absolutely fundamental. And if it's a part of the fundamental nature of reality, then it must be explained by the physics. Even if we have a theory that can explain all the 4 fundamental forces in a single framework, that will not be a theory of everything if that does not, until and unless that does not explain consciousness. Because according to me, consciousness is absolutely fundamental. And there are some new sciences coming up like chaos theory, science of emergence. So far we have been discussing this physics standard model and everything. We are following the reductionist approach. To understand a thing, we are breaking it down into smaller and smaller parts and then seeing what it is made of. It's made up of quarks, leptons, fermions, bosons. Bosons, it's not made up of bosons. Bosons are the particles, the exchange of which gives rise to forces. So basically we are studying what they are made of, but we are studying them. But for instance, consciousness. If I take out a single neuron out of my brain and if I study the neuron, my brain is made up of neurons, neural connections and synapses and neurons and some chemicals, neurotransmitters, nothing else, and some brain tissue, that's it. But if I study the individual atoms or individual neurons, will I be able to understand consciousness? Will I be able to understand, will I emerge out of the single atoms? No. For that I need to study emergence. I need to study how it is all coming, like how it is all fitting together, how it is all interacting with one another. This interaction is also crucial. And it's like the greater than the sum concept. So yeah, that's very like we should, I definitely think we should try to reconcile physics, consciousness, and to some extent maybe even metaphysics. And that's the 6th problem. Now the 6th problem is not a problem in theoretical physics, because theoretical physics does not deal with consciousness, but it's a problem in physics, I would say. At least in the future I see that physics and consciousness should merge. And so that's all I wanted to say in this video. Just a small discussion, and more such discussions are coming, and I'll be making more educational videos. Like for those of you who are studying in class 12th in India, as you already know, I drop a lot of educational videos. So if you want to support me, please subscribe to the channel and like my videos, share them, comment. So that's all, guys. Thank you. Any questions, anything you would like to discuss, just leave a comment. I will definitely check it out.